Okay, this is your pre-calc lecture for lesson 75. All right, lesson 75, even though you can read it right there. And this is on combinations. And I'm going to go ahead and give you the formula for it right now, but I'm still going to explain it. So there is a formula for combinations, and it's n factorial over n minus r factorial times r factorial. And this is the combination of n things taken r at a time, if that's alright. That doesn't even look very nice. There it is. Okay, so hopefully you can read that. And this is in your book too. So now I gave you the formula, but I'm going to try to tell you what's the difference between the combinations and the permutations and when you want to use this one. So you guys have seen permutations before, where we just say, like, we might say something like, how many passwords can I make out of the letters A, B, C? And then you'd go, remember we used to do this, I'd say, how many passwords can I get out of the letters A, B, C? And you'd go, oh, well, there's 3 letters, and then that letter took up a spot, so then there's 2, and then there's 1, there's 6, right? But in a password, the order of the numbers matters. You know, like I could say that ABC could be a different password from ACB, right? I mean, just because it has the same 3 letters, the order matters on a permutation. Okay, so there's going to be more, I don't want to say combinations, there's going to be more passcodes that I can get out of the letters A, B, and C if the order matters. But on combinations, let me write this, the order doesn't matter. Doesn't matter. So an example of that would be, I'm going to pick 3 of you to be in my special math group. So if I pick, say, like Sarah, Chantel, and Seth to be in my math group, it's not like it's a different math group if it's Chantel, Sarah, and Seth. You know what I mean? Like, it doesn't matter what the order is. So you're going to use combinations for some of these types of problems where we're just choosing a group or choosing a team or something like that. When you're making passcodes, then you're probably going to use some permutations, combinations, and you can see there's going to be fewer of them, because if you can remember, I don't know if you remember this or not, but permutations looked like this: n factorial over n minus r factorial. I don't know if you remember that or not. That would be n things taken r at a time. See how this one has an extra thing? It's got an r factorial on the bottom. So by having a larger denominator, it actually makes there be fewer, fewer outcomes. Okay, so this is when order does matter. That's when you use a permutation. Combination, so that's the only thing new we're learning, is that combination, it has the little extra r factorial down there, and it's when order doesn't matter. And so they kind of show it in your book. They say we're kind of dividing out, that little extra r kind of removes the effect of order mattering. And then it gives some, let's see, what else do I need to say? Oh, I'm going to show you some different notations. Your book shows you some nice notations right here. So, if you can even read that, you can write it like permutation of n things. You probably can't read that, can you? I'll write it like this. Permutation of n things taken r at a time. This is the notation that I prefer to use. so you'll see me using this, but there are also other notations that mean the exact same thing. This one, I haven't seen that one too often. Sometimes I'll do it like this, and things take an R at a time, or and take an R at a time. Okay, so, and same thing with, those are permutations. Permutations are when the order matters. Combinations when the order doesn't matter. So you can look in your book at the different ways. I like the way, this is the way I do it, and things take an R at a time. That's combinations. Okay, so, I think that's all I want to say about it, and then we'll just do some problems. So what problem are we supposed to do? We want to do 75, number 6. Let's do number 6. So number 6 says, how many ways can a committee of 4 people be selected from a group of 8 students? So that's kind of like what I was saying about my little math group. I'm going to grab a math group that has, you know, a certain amount of people in it, but the order doesn't matter. Like, the order that I pick the people doesn't matter. They're all still going to be on the same group. So that tells me that I have to use a combination. So this is 75, number 6. So I know that I'm going to use a combination, and I have my formula right up here, actually, so you can probably see that. Let's cover up the other combination. So in this problem, how many ways can a committee of 4 people be selected from a group of 8? So 8 people taken 4 at a time, right? So that's the total number of people, and that's how many I'm going to select for my group. I know it's combinations because it's like a committee and the order doesn't matter. Okay, so n factorial, that's 8 factorial. And then this will be n minus r, so 8 minus 4 factorial. But then since order doesn't matter, I need r. See r. And that's going to be 4 factorial. And then you can just go, you know how I like to do this. Well, first I'll do it all out the long way. 8 minus 4 is 4. And then this one I like to go 8 times 7 times 6 times 5. And then I think of the 4, 3, 2, and 1 as canceling out with one of these. But then I still have this one, so I still have to go 4 times 3 times 2. I never write the ones. And then in this case, I'd probably take 4 times 2, cancel it with the 8. Take the 3, cancel it with the 6. 7 times, 5 times 2 is 10, and 10 times 7 is 70, so that would give me 70. So there's 70 ways I can choose a group of 4 students out of 8. If I have 8 students, I can choose a group of 4. Or 8 students taken 4 at a time. So that's number 5. That's number 6. Yep. Okay, I'm going to do another video, so you better look at the other video for our next lesson, lesson 76. Oh wait, there's something else. Oh wait, no there's not. Okay, tune into the next video.